Writing and solving systems to model situations. Step 1, define the variables. Step 2, analyze components and create equations. Step 3, solve the system using the best strategy: graphing, substitution, or elimination. A total of 292 tickets were sold for a basketball game. An adult ticket costs $3 and a student ticket costs $1. Ticket sales for the event were $470. How many adult tickets were sold and how many student tickets were sold? Step 1, define your variables. We're going to let A equal the number of adult tickets and S equal the number of student tickets. Then we're going to set up the system of equations. We know the total number of tickets sold, A plus S, is 292. We also know that the money collected, which is 3 times A plus S. So because these adult tickets were $3 and student tickets were $1, we can set it up like this. We know that when you add up all the money, you get $470. Then you solve the system. We know both of these things are true, so we can do different strategies. Here we're just going to subtract one equation from the other, which will get rid of the S's, solve for A, and we see that 89 adult tickets were sold. Alright, so because we know there's 89 adult tickets sold, that means that we can plug it into this equation, subtract 89 from 292, the total number of tickets sold, and we see that there's 203 student tickets sold. And we can check by plugging our values back into our original equations, and yes, they do work out. A group of 148 people is spending 5 days at a summer camp. The cook ordered 12 pounds of food for each adult and 9 pounds of food for each child. A total of 1,410 pounds of food was ordered. Write an equation or a system of equations that describes the above situation and define your variables. Then, using your work from Part A, find the total number of adults in the group and the total number of children in the group. Let's let A equal the number of adults and C equal the number of children. The easy equation is just the total number of people, A plus C, which is 148. The slightly trickier equation is this one. We have 12 pounds of food for each adult. So we take 12 and multiply it by A, the number of adults. Then we add it to 9 times C because we have 9 pounds of food for every child. We add up those and we get 1,410 pounds of food. Now we have our two equations and we can solve the system. Alright, the first step is solving this equation for C. By the way, there's several different ways to do this. This is just one method. Then we take this equation and plug the equation for C in for C. So since C is equal to negative A plus 148, we then write the second equation, but instead of C, we plug in the other equation. So instead of C, we put negative A plus 148. Then we solve algebraically. We distribute the 9, we group like terms, we subtract 1,332 to the other side, divide by 3, and we get that the number of adults is 26. Then it's simply going back to our first equation, plugging in 26 for A, and solving for C, which would be 122 children. Tanisha and Rachel had lunch at the mall. Tanisha ordered 3 slices of pizza and 2 colas. Rachel ordered 2 slices of pizza and 3 colas. Tanisha's bill was $6 and Rachel's bill was $5.25. What was the price of 1 slice of pizza and what was the price of 1 cola? Alright, so here's our two equations. We're going to let P equal the cost of a slice of pizza and C equal the cost of a cola. We know that 3 slices of pizza and 2 colas equaled $6. We also know that 2 slices of pizza and 3 colas equaled $5.25. We have two equations with 2 unknowns, so we can solve the system of linear equations. Alright, so we're going to use the elimination method. We're going to add the 2 equations together, but we're going to change them slightly so that something gets eliminated. We're going to multiply the first equation by 2 so that this 3p becomes a 6p. We're also going to multiply this equation by negative 3 so that this 2p becomes negative 6p. Now when we add these equations together, the p's go away. They're eliminated. 4 plus negative 9 gives us negative 5c. 12 plus negative 15.75 gives us negative 3.75. Divide both sides by 5 to get the cost of the cola as 75 cents. Then we just pick either equation, plug in our value for c, and solve for p, which is $1.50. 22 people are going on a trip. Among those 22 people, there are 4 drivers. There are also 2 types of vehicles, vans and cars. The vans seat 6 people and the cars seat 4 people, including the drivers. How many vans and cars do the people need? Let V equal the number of vans and C equal the number of cars. The number of drivers is 4, which means there's going to be 4 vehicles total. So V plus C is going to be equal to 4. We're going to solve that equation for V because we're going to substitute it in over here in our number of people equation. We know there's 22 people total, and we know 6 people fit in each van and 4 people fit in each car. So we're going to take that negative C plus 4 and plug it in over here for V, right there. Then we're going to do some algebra and solve for C. Distribute the 6, combine like terms, subtract 24 to the other side, divide by negative 2, and we get that we need 1 car. Then we plug that C back into the original equation over here, and we see we need 3 vans. Suppose you're walking to school. Your friend is 5 blocks ahead of you. You can walk 2 blocks per minute, and your friend can walk 1 block per minute. How many minutes will it take you to catch up with your friend? Write a system of equations to model the situation. Use the equation d equals d naught plus st, in which d is distance, d naught is the initial distance, or where you are at time 0, s is speed, and t is time. So you have an equation where you're starting at a position of 0, your friend is starting at a position of 5, so 5 blocks ahead of you. Then you walk at a speed of 2 for a certain amount of time. She walks at a speed of 1 for a certain amount of time. So d equals 2t, but d also equals 5 plus t, because when the d in this equation is the same as the d in this equation, both people will be at the same position, which is when you catch up with the friend. Next, make a table to represent the problem. So this is another way to solve a problem like this. So we're just going to plug different times into these equations and see what we get. At time 0, this goes away and we have 5. This goes away and we have 0. So this is your friend's distance. This is your distance. After 1 minute, your friend is at a position of 6 and you're at 2. And you can see 7, 4, 8, 6, 9, 8. And then finally, after 5 minutes, you are at the same place. You have met. Next, you can plot those points on a graph, and you can see that we have 2 straight lines that intersect at 5 minutes. The point where the lines intersect is the solution to the system. 5, 10 is the solution. In the context of this problem, this means that after 5 minutes, you will meet your friend at block 10. However, a much faster strategy would have been to just use substitution. We start with one equation, put it here. We have this d here, but we also have d equals 2t. So just take that 2t and plug it into the first equation for d. Then solve for t, and we get 5. Then if we take that 5 and plug it back into the original equations, we do get distances of 10.